All right, everybody. Welcome back. So last class, we were starting our discussion on algebraic proofs, where we start with what is given to us, and then we explain it in the right-hand side of our table, if you will. Then we go back to the left-hand side and we do our next step. Then right across from it, we give a justification. We say why. So we use a lot of addition property of equality or subtraction property of equality, division property of equality, so on and so forth last class when we did algebraic proofs. Starting today, we're going to be using everything that we have talked about up to this point. So addition, subtraction, multiplication, and division properties of equality. But we are also going to be talking about all the other things as well. So a couple days ago, you guys learned the segment addition postulate, which you will see on your screen here. If you have a segment, meaning a finite piece of a line with at least 3 points, then you can add those smaller portions of a segment to get a larger segment. So for example, I probably should have drawn this before I started this video, but it's fine. We'll do it this way. Okay. So for example, with segment addition postulate, just using the what's here, if Q, okay, so if the point Q is in between the point P and R. Okay, so here we have one large segment, PR. Remember that that is named, or it is written as PR with an actual segment drawn over the top. Okay, so if point Q is between PR on the segment, then what does that mean? That means I can say the measure of segment PQ plus the measure of QR equals the measure of segment PR. Notice how all of this is written. It's not written with the segment bar over the top of PR. It's just the letters. Okay, that's going to point me down to this statement down here at the bottom. Oh, my arrow is a little backwards. I'll fix it. The only way that I'm allowed to do something like that, okay, that would be like saying, let's say Faith plus Faith, because my first name is Faith. So, or Faith plus Brett equals 11 feet. Okay, does that make any sense at all? Faith plus Brett equals 11 feet. Does Faith in itself have a measurable value? Does Brett have measurable value? Well, not in that format, no. But what if I said the length of Faith plus the length of Brett equals 11 feet? Okay, now we're cooking. Okay, now we have something that is measurable. We have numerical values that we can combine, we can add together, or we can subtract together. Okay, if I said Brett minus Faith equals 1 foot, that doesn't make any sense. But if I say the length of Brett minus the length of Faith equals 1 foot, that makes sense because Brett is 6'4" and Faith is 5 foot 4 inches. So if I subtract those, I get 1 foot. Okay, so what does that mean? That means anytime we try to manipulate segments, if we try to add them, we actually have to add their measurements. So we cannot add congruency. We can't add names, if you will. So just like Faith plus Brett doesn't tell you anything, the measure of Faith plus the measure of Brett, or the length of Faith plus the length of Brett, that gives you a numerical measurable value. So what does that mean for you? When we are dealing with proofs, you might occasionally end up with something like this. I might tell you, here's segment PR, and let's do another one. Here's segment PQ. We'll just keep using what we already have. For the record, you might hear my child in the background yelling puppy or some other words. I apologize. She just woke up from a nap, so she's really excited. Anyways, back to geometry. Okay, I know, baby. Hi. Right now I'm dealing with segment PR and segment PQ. Okay. Well, the only way that I can get from here to there is if I get rid of those segment bars. Okay. And the only way I can get rid of those segment bars is if I go to the definition of congruent segments down here at the bottom. Okay, I will highlight that for you so you know which one I'm talking about right now. Okay. The definition of congruent segments is simply that. I can change a congruent segment to say the measure of this segment. Okay, so instead of faith, I can say the measure of faith. And then I can actually start adding and subtracting things. I can start multiplying, dividing things. Notice this symbol right here. Let me change the color. That is a congruency symbol. So we would use congruency. Okay, this is something that you should have covered from your textbook or from some earlier videos, but if not, I'm just covering our bases just in case. Congruency is when we would say something like segment AB is congruent to segment CD. We could say that those segments are congruent to each other. Why? Because names, official names, are congruent. Okay. And congruent, the congruent symbol is just the equal sign with a little squiggle on top. Okay. But if I want to add anything to segment AB or subtract anything, if I want to manipulate its numerical measurable value at all, before I do anything else, I have to say, instead of segment AB is congruent to segment CD, I have to change that or convert it, if you will, to the measure of AB is equal to the measure of CD. And the only way that I can make that statement is by the definition of congruent segments. Or if you want to shorten it, just the definition of congruency. Now that I have it in that format, I am free to add things to both sides. So I can add 5 to both sides by the addition property of equality. I can add another measure of a segment to both sides over here if I need to. And I can do that by the addition property of equality, and so on and so forth. I can look at a diagram. Hold on just a second. Let me pause this video. Okay, so I'll pause the video just to kind of create a space for just an example right here on this screen. We'll revisit in just a sec, but I just wanted to have one right here alongside all of our rules. But so for now, what we've seen, what we've discussed is just reviewing some things that we've already been doing, what things that we've already learned. So segment addition postulate, that is when we can add pieces of a segment, measures, emphasis on measures of pieces of segments to get one big piece. If our segments are not written in the measure of format, so like this without the bar over top, then we have to convert them to the measures of segments using the definition of congruent segments. Okay, then we can do something like segment addition postulate where we add them up. Okay, word of advice before we get going on these proofs, that is going to be a pattern. Okay, I'm going to start you out with something, and if it is a segment name, the first thing you're going to want to do a lot of times, okay, not every time, but at least starting out here, one of the first things that you might want to consider doing is converting them to the measures of segments using the definition of congruent segments. Then after that, you can begin adding pieces of segments using the segment addition postulate. Okay. Now the midpoint theorem, we covered this last class. We covered how to find the midpoint. We covered what the midpoint looks like in your homework for last class. You should have seen some examples of a midpoint. Okay, I want to review that just very quickly. Let's see, I'll put it up here. Let me change these letters. Okay, so our midpoint theorem says is M is the midpoint of segment AB, then AM is congruent to segment MB. All right, so let me cover the hypothesis part. Notice that that is a conditional statement. If M, okay, if M is the midpoint of segment AB, so segment AB, okay. All right, so right now it looks like I have a segment AB, with M as a point somewhere on it, but it doesn't look like it's in the middle, okay? So how do we know, how do we write or label our diagram to show that it is a midpoint, okay? Well, here's the way that we do that. Again, right now, I purposely put this point kind of somewhere offset. It doesn't look like it's necessarily in the center of that segment. But diagrams are not drawn to scale in geometry. That is to make you learn how to label diagrams well. Okay, so let me show you how to label the midpoint of a segment. Okay, if something is the midpoint of a segment, what we talked about last class was that midpoint is the point in the middle of the segment, meaning it cuts the segment in perfectly in half. So if M is the midpoint of segment AB, then that means AM's measure is the same or equal to MB or BM's measure. Okay. That also means if their measures are equal, then the segments themselves are congruent. What did I just draw? I just drew something called congruency marks. They kind of look like tick marks, but what they do is they just mark, all right, these things, if they have the same markings, then they are congruent, which means by the definition of congruent segments, they are equal in measurement. So segment AM has 2 congruency marks. Segment MB has 2 congruency marks. Because they both have the same number of congruency marks, then that means that segment AM is congruent to segment MB, which is exactly what the midpoint theorem states. Okay. Now there's another one down here. That is one that you can learn, but I'm going to advise that you don't learn that one, because here's why. There's a lot of rules in geometry, and if you can reuse the rules that you already know, I suggest that, okay? So if you get to this statement where it says segment AM is congruent to segment MB, but you want to convert that to be an equal statement or an equation, then all you have to do is convert it to the measure of AM equals the measure of MB using the definition of congruent segments. Okay. So these are your big 3 geometric theorems or postulates. Other things that you will use are substitution, property of equality, addition, subtraction, multiplication, division, all the ones that we used last class when we started algebraic proofs. Okay. So with that in mind, I want to do one example. And then from that example, we will go from there, and I will give you some other examples with some other people talking you through those steps. You'll notice on your course calendar, we're going to take a couple days on this because it's a complicated process, and we want to make sure that we are solidified on it. So just hang tight. If you don't fully get it today, that's fine. It takes a while. Geometry is complicated in that it's completely different than what you have done before. It's brand new territory. Brand new territory takes a while to learn, takes a while to get adjusted to and to learn differently, if you will. So just hang with me. If you need to pause this video to copy this down, please do. The diagram is right here. What you are given and what we are trying to prove is here. So pause the video if you need to. All right. So the first thing we want to do in a proof always is to look at what we are given and look at what we are trying to prove. Label our diagram if there's anything that requires labeling. Okay, so we can only label it with stuff that we are given. That makes sense. Like I can't eat an apple unless it is given to me or unless I go get it. Okay, I can't just, oh, it appears. Okay, I have to be given that apple or I have to go get it. And so in this case, we are given segment AB is congruent to segment CD. So before I get started doing anything else, I'm going to mark that on my diagram. Segment AB is congruent to segment CD. I only used one tick mark each or one congruency mark each here. That's totally fine because AB has one congruency mark and CD has one congruency mark, which means they match up. Okay. Now, what we talked about last class, again, a quick review. Your first step in a proof is always what you are given. Your last step in a proof is always what you are trying to prove. You are not done until you have your prove statement. Okay. If you don't get that exactly in the right order, exactly how it's written, then you keep going until you get there. Okay. So first step in a proof is our given. Segment AB is congruent to segment CD. How do I justify that on my right-hand side? I write given. And again, we already talked about this. That's why it's already written under here. But let's talk through it again as if we were doing this problem completely brand new. Okay. Look at what you were given. Look at what you were trying to prove. The first thing that I notice is that this is a congruency statement and this is an equal statement. These are segment names. These are the measures of segments. What rule allows me to get from segment names to the measures of segments? And that would be this one right here, the definition of congruent segments. Well, the only thing that we have been given is this congruency statement. So the only thing that we can use right now is that. So work with what you got. Literally, I've got a congruency statement. The only thing I can do with it right now is to convert it to the measures of those segments. The measure of AB equals the measure of CD. Why? What is my justification? The definition of congruency. Okay, so go back to what you were trying to prove. Remember, that's what we are working towards every single time. So we are trying to prove that the measure of CD plus the measure of BF equals the measure of segment AF. Okay, so that's kind of a complicated thing. It looks a little weird, but we'll get there. What rule allows us to add the measures of segments? Because we have to do that. Our proof statement is adding the measures of segments. So we have to do that at some point. We've kind of run into a dead end at this point. We can't do anything else with this statement except hold on to it in case we need it again. So what other things have we learned that allow us to add the measures of segments? Right here, the segment addition postulate. So let's go back to our diagram. What measures of segments can we add? Well, the first one I see that I can add is this one, the measure of AB. So the measure of segment AB plus the measure of segment BF equals the measure of segment AF. How do I know that? The segment addition postulate. Now, if you did not learn that from earlier this week and last week, then you're far behind. and you're going to be really confused. It's going to take you a while to catch up. Okay. If you did not learn this, you need to back up to in your course calendar where it said segment addition postulate and review that or do that lesson. Watch those instructional videos and go from there. If you maybe need some more practice in that, you can go back to that section's homework and practice that. Okay. How am I able to say that? The segment addition postulate. That is my justification, if you will, my explanation as to why I can say this plus this equals that. Is there anything else that we could use? We have two segments. So can we do segment addition postulate again? Sure. Okay. For that second segment, let's do the measure of CD plus the measure of DR. What does it equal? The full segment, CD plus DR equals CR. And why am I able to do that? Okay. I'm also able to do that because of the segment addition postulate. All right, so we're not done yet. How do I know we aren't done? Because we do not have this exactly at the end of our proof. We don't stop until we get to that. And the only way we get to that is if we use the resources that we have, which are all those properties of equality from last class and these three rules. Okay, so let's look at what we are trying to prove. We are trying to prove, let me do some highlighter stuff for us. I love color coding things, can't you tell? Okay. The measure of CD plus the measure of BF equals AF. So to me, in my mind, I start running through that and going, well, this is segment addition postulate, but the pieces aren't connected. How can I get CD in relationship with these other two pieces? Because AB is in this spot right here, but I don't need it for my final statement. I need it for CD. All right. So other thing to think about is look at what we have done so far. We have that AB equals CD. So these two pieces equal each other. Well, if they equal each other, why can't I take this guy out and put this one in its place? Because if their measures are equal, then that means I can substitute them. I can swap them out. That sounds reasonable to me. Look at some of your other things. We have it written out here. AB plus BF equals AF. Well, this step is really close to what we need. The only difference is AB has to go and CD's got to come in. Is there anything that we have written in this proof that tells us AB equals CD? If they equal each other, we can substitute them. Can you find it? Because what I see is if AB needs to go and CD needs to go in its place, here it is. If AB equals CD, then that means I can take this out and I can substitute CD in its place. So I'm going to do that for my next step. Instead of AB, I'm going to substitute CD. Okay, if you need the visual there, here it is. Okay, so instead of AB, I'm going to plug in, or I'm going to substitute the measure of CD, and I'm going to keep everything else the same. Why? Because I don't have anything else that I can. First of all, there's nothing else up above in my proof that I can pull to substitute. This is it. Why can I do that? Why am I able? I've already said that rule several times. Why am I able to substitute AB out and put CD in its place? Because of the substitution property of equality. Okay. Now pause. That's a crazy radical step. It hurts our brains, probably a lot of us, especially my golds. Like you'll figure this out, but it probably frustrates you because it's a very global way of thinking. Like it's not step A, step B, step C. It's all right, I'm gonna go to step 5, but then I gotta bounce back up here to the second one. You're kind of all over the place. You got to hold on to everything that you need. So what do we need? How are we supposed to end our proof? We're supposed to end our proof saying that the measure of CD plus the measure of BF equals the measure of AF. Do we have that here? If I have it, I'm done. And I do. Okay. I do have exactly what I need, which means I have finished with this proof. It took me 5 steps. It might have taken you 4 steps, depending on how you wrote it. Like you could have combined these two together as one step because they are by the same rule. Okay. This is pretty much the only way that you could have gotten to this step, though, just because of how basic this problem is. So what does this mean? You need to practice, 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 practice. We are going to practice, practice, practice in class. Okay. But I need you to practice at home first. Bring all of your questions into class on, I guess, Tuesday, so that we can really nail this down, so that we can really figure out what we're struggling with and how to be better. Okay. How to grow, how to understand it better. Okay. Look for some other videos in your course calendar and through ThinkWave on segment proofs, and we will go from there. Don't become impatient. Don't lose your resolve. Like persevere. Take a break if you need to. Like I do not want you to stare at a video for an hour in frustration. I want you to maybe try one problem. If you're frustrated, step away. Maybe do a different subject, break for lunch, or in our house as a snack for the baby. Like go take a walk, get up, move around. Don't just sit there idly for an hour. Like don't let yourself get frustrated to where you quit. Step away from it and then come back if you need to. Write down your questions and we will discuss all of them in our next class.